And welcome back. We're now in section 4.2. Operations with matrices. There are two operations we're going to do. We're going to do addition, subtraction, and scalar multiplication. We are going to do regular multiplication, but it's so complicated that we're going to cover that in section 4.3. It gets a whole section to itself. Alright, these three operations are pretty straightforward, and I'll teach it mostly by just doing examples. Alright, so let's get started. Example 1. What's going to happen is, I'm going to just ramble as I write some matrices down. We're going to take it each element by element and add them or subtract them. So here, so we just add it element by element. 1 plus 0 is 1. Negative 6 plus 1 is negative 5. Did you hear that dung sound again? I gotta learn to deal with that. Alright, sorry. Then we do 5 plus 3 is 8. 2 plus negative 4 is negative 2. Negative 4 plus 6, positive 2. 3 plus 7 is 10. That's addition. Let's do an example of subtraction. Okay, so 1 minus negative 2 is going to give me 3. 4 minus 6 is going to give me negative 2. Negative 7 minus 4 gives me negative 11. 3 minus negative 3 is 6. 6 minus 1, 5. 0 minus negative 2, positive 2. Easy peasy, lemon squeezy. Alright. Let's go on. Let's look at scalar multiplication. Scalar multiplication is like the distributive property. You have a number outside of the matrix. I can't help writing these in order. Sorry. So all you do is multiply the 3 with every element in the matrix, or every cell in the matrix, or whatever you want to call it. So 3 times 1 gives me 3. 3 times 2 gives me 6. 3 times negative 4 gives me negative 12. 3 times 5, 15. 3 times 0, 0. 3 times negative 6 is negative 18. Alright. Let's mix it up some. I don't think it's going to fit over here. So I'll write it over here. Okay, so it's 1 minus 3 times 2. So it's 1 minus 6. Making it negative 5. That's a 5. Negative 2 minus 3 times negative 6. So it's negative 2 plus 18. So that's positive 16. 0. Negative 3 times 7 is negative 21. Down here, 4 minus 3 times 3, so it's 4 minus 9, which is negative 5. Negative 6 minus 3 times 0 is 0, so it's negative 6 minus 0, making it negative 6. 3 minus 3 times negative 1, so it's 3 minus negative 3, or 6. There. Alright, keep going. Another example. Let's do something a little more interesting. I'm going to do a columnar matrix here. I want to point out here, this is considered one element in a cell. It's one thing, one term, one whatever, one thing in a cell. Even though it looks like it's two things, that plus sign means I'm combining them. Okay, I'll do another example where the distinction will be more clear after this. All right, so when I combine these two, I'm basically combining just like terms. So I'll go x squared, 2x and 3x makes 5x. A little reminder, this has an exponent, this one doesn't, so I cannot combine them. Remember, when you're combining like terms, that they must have the same variable or variables and the same exponents on those variables. So on this one, x minus y plus 1, nothing can be combined other than like that. And the last one, x plus 2x makes 3x. This is still, that's still one element, one element, one element. So this is still a 3 by 1 matrix. Okay. The reason why I'm pointing that out is some people look at this and they say, "Oh, this is 3 things. Is this a different size matrix?" But it's not 3 things. It's 3 things in a polynomial, but it's not 3 things in a cell in a matrix. Let me do another example. Okay, notice this is a 2 by 3 matrix. This is considered one cell, this is one cell, this is one cell. How can you tell the difference between something that's considered one cell and what's not? I will try to put space in there. There is no operation between them. Right? If there is an operation, that means you need to group them together as if it were one entry in a cell. Alright, let's do this one. So it's x plus 3x, making 4x, 2x plus y, x minus y plus x plus 2y is going to give me 2x plus y. X squared plus 1 is 2x squared plus 1. X plus 3 plus x is 2x plus 3. And 2x minus 4y plus 3x gives me 5x minus 4y. Okay, and that's it. No, yep, that's it. Hope that helps. Okay. Now, after we've seen all those examples on how to add and subtract matrices, what happens if they do not have the same dimensions? Let's say I have this example. I don't know why I keep numbering it like that. I can't stop. Well, you can't add them. If two matrices have different dimensions, they cannot be added. So we simply say that this is undefined. This also goes for subtraction. You don't have to do anything. You just need to recognize that they have different dimensions and cannot be added, and you simply state undefined. That's it.